Assalamu alaikum everyone. Welcome back. This is the last part of this practical PCR AFLP, and I just want to let you know that we have done all these things in our own lab. We had a project of breed identification markers for local dairy cattle, funded by the Pakistan Science Foundation generously, and in that project we did all this PCR of an AFLP method. So there are different steps. In the first step, I just want to clarify we use the WAS 1995 method in detail. So simply we cut the genomic DNA in small fragments, and we use EcoR1 and TAG1 enzymes, and we have the adapter similar for these EcoR1 and TAG1 enzymes, and those adapters they ligate with the uh, specific you can say uh, these fragments which are cut, and then they are amplified. That is the pre-amplification process. I will give you the sequence of the primer index, and this is the PCR conditions which we used. Then after that we use the selective amplification. Once we have pre-amplification, we run the gel on the polyacrylamide gel, we'll run the results on the polyacrylamide gel, and then find the fragments, and then those fragments they are separated and they are selectively amplified. And selection with selective amplification means that, for example, here is the first primer echo 1, 5 prime to 3 prime, and then we add AC at the end of this primer, then AG, then CA, then CT, GC, GA, GT, TC, TG, likewise that. So these help us to produce the selective amplification. Similarly for the tag primer, uh, now after that selected, we again run on the polyacrylamide gel. That is a quite complicated stuff to join all the component of the apparatus, as well as to have a right combination of the chemicals used in this experiment. It needs a lot of expertise, so we use these chemicals in these ratios, and then once we got all these clones and have specific primer for that, then we what did we do? We went for the sequencing of these fragments, and then identified the specific SNPs, and based on the SNPs we developed the markers. And finally, the statistical analysis with the help of the Harlequin software, or you can use the SAS if you have. Definitely, you need a license for the SAS version. Thank you very much. Now the sequencing. I just in the last slides I talked about the sequencing, and Sankey sequencing is one of the most important sequencing method. And simply what we do, we in sequencing we use the raw material A, T, C, and G to build the DNA, and that DNA is read by the machine, and in this way machine will give us the sequencing. But in the Sankey sequencing, one of the most important thing is the chain terminator. So chain terminator basically they are fluorescent, and they are labeled, you can say the nucleotides, and when they terminate they eliminate the light and be detected by the machine and then read by the machine. Okay, simply the sequence of the A, T, C, G in the given piece of the DNA, that is called the sequencing. How we can determine it? In Sankey sequencing, we can sequence up to the 900 base pairs in a single go. We use PCR to get that sequencing, and here is dideoxy chain terminator, DD ATP or DD TTP or DD CTP or DD GTP that we use to terminate, and this termination is basically read by the machine. Here you can see the difference between the dideoxy, which have the hydrogen at the position number 4, while the deoxy it have the hydroxyl group at position number 4 in the sugar backbone. So this is Sankey sequencing, a brief method. You can go through it. Most of the things I have briefed you about the Sankey sequencing, but after the completion of all the cycle of the termination, you will be getting the sequence of your desired DNA. This diagram elaborates to more. We have a primer and we have a template which we want to get sequenced, and we have DD TTPs in the system in the that solution, and we preheat that. And after preheating the primers, then again we drop the temperature and primer anneal with your template, and then starts its amplification. And then on subsequent intervals, on a regular interval, DD, TTP, or these nucleotides, they are added. And once they are added, there is a chain termination. And once we have all these fragments, they are passed through the capillary gel electrophoresis. Here you can see capillary gel in black box, and laser and the detectors, they basically read these signals and they transfer to the computers, and the computers then eventually generate a chromatograph, and it can, the company also give you the text form of this sequence. So here is the text form which we retrieve from the company for our own experiment. I have just told you about the PSF project. Then the results in the form of the chromatograph are shown over here, and that's all. Now these results, they are blast on certain genome browsers or databases. Uh, for BLAST procedure, we select a BLAST program, then enter the query sequence which we are getting as a result of the sequencing from the company. Then the database search it, and we give certain parameter to search for that, and then we run the BLAST. And finally, we can also design the primer. That is also part of your course. I will explain to you. So these are different, the search engine, NCBI, the UC Davis, browser, both are from the USA, EMBL from the Europe, DDBJB from the Japan, and the last one BIDG from the China. So mostly we use the NCBI, and NCBI is connected with the EMBL and DDBJ. So in this way, if you are going on the NCBI, you are also getting access to another two uh, um, databases. Now I will explain to you how we can go for the sequencing. Just let me open that file from the uh, the Google Drive. Wait for a minute, please. Microphone. Give me a minute. Cancel it. And again double click so that it can. Yeah. Here you can see Chrome. It will show you the window. Okay. So we go here. So just let me go back where I started. Okay, here is the website ncbi.nlm.nih.gov. So this is from the USA. You can simply click on the blast. You can see on your screen. Yeah, blast option is there. Just click on the blast. Right, and it will open the different options for the blast. Here you can see you can have nucleotide blast, which we will be using in this current scenario, or you can have blast X that will translated nucleotides. They are blasted against the proteins available in the database, or the proteins sequences. They are blasted against the translated nucleotide available in the database, or finally you can blast protein against the protein. So we are going with the first option. Okay, so here is the one sequence which we have received from the company. We just paste over here. Yeah, as a result of our own experiments and standard, these are the different parameters which you can set. But you must know what parameter means what in this on this BLAST experiment. So just click on the BLAST. You can show result on the new window, but I will not going to do in this current scenario because I want to record the video. Just click on the BLAST and it will give you result in few seconds. Yeah, it's running, searching on the web on the database. So comes up with the results. Right. So here you can see the Boss torus isolate this one, and you can see the maximum scores, total score 25% query coverage, and identity is 99%. And you click on that, and you will get that sequence. So in the bottom is your subject, and here is your query. Subject means this is the sequence available with the database, and the query is what you have asked from the database to get it sequenced. Now here with this one, and if we go back again to the home, we can go with the primer designing for this sequence. Once you go to the home, and just command find primer. Yeah, primer blast here. So just paste your sequence, and then you have different options over here. For example, I will go for 70 or 70 to 200 base pair. Depends on your subject DNA sequence. Then these are different temperature options, annealing and melting temperature for these primers. Then if you have any reference, you can give over here, or intron in the reference, or the specificity, anything you want. So you must be well versed with all these terminology before you use these options. And if you click on the get primers, you will be getting the primers for these sequences, for this specific sequence. And it might give you more than one options, and then among those options you have to select which one is the best one depending upon its GC contents and other parameters. So here at this stage I will love to tell you that there are some other specific primer designing tools such as Primer Premier. But these softwares you have to pay for that. Check again to get its license and design the primers. Okay, here we come with the primers. So 77 base pair, 70, and you can choose again more bigger primers by going on the options, loading details. It will be the graphical view. Yeah, here. And if you give it more bigger size, it will give you more results. For example, if you go back and give its option, oh no, just hold on a second. Sequence is there. For example, here I want minimum size and maximum size is minimum is 10. I don't know it will work on that. Minimum is 20, or you can say minimum is 200 and maximum is, for example, 400, or you can say 300 and 400 whatsoever, depend on the size of your fragment. And then again click on the primer, get primers, and just click on check. No primers are found, so we have to change our window. Maybe hold on a second. You can give it 200 to 201. Check. Hmm? So here we come with the results. 201 base pair is your product size. You can see on your screen, and here it will be showing the graphical view. You have to wait for a few seconds to watch this graphical view, where it will be showing the forward and reverse primers designed for you. Yeah, you can see the primer 1, primer 2, primer 3, primer 4. There are 4 different options, forward and reverse primer, and depending upon the other parameters like GC contents and many more, you are the hair conformation and etc. You have to decide which primer you are going to use for your PCR. So that's all about your course practical part. Thank you very much, and please be prepared for your examination. It depends on the policy of the university how it is going to conduct the exam. Thank you. Allah Hafiz.